Okay, hello and good morning. Let's take a look. We're in week 6. For those of you who get extra time, I opened Albert IO, and this will be the only time till the 30th. See me if you did the work. There's a sign-up sheet on the wall. Make sure you're very specific about which one you did so I can verify it. I will check after the 30th. Extra time on the test number 1. Test number 1, the last day is today, so if you needed extra time, there it is. All right, let's go over these. This means and. This is a negation. If they say is, you say is not. If they say is not, you say is. This one actually is the or. Change that. This one is the and. And make sure you know that. All right, let's take a look at these down here. This is and, so P and Q. So you're going to say, the tour goes to Italy and we go to Venice. This one you're going to say not P. So the tour does not go to Italy and we will not go to Venice. This one is or. The tour goes to Italy or we will not go to Venice. This one is if then. If the tour goes to Italy, then we go to Venice. This is a biconditional if and only if. The tour goes to Italy if and only if we go to Venice. And if and only if you use IFF. If you want to write it out, you can. Okay, so now that we got off of that, we're going to go over a truth table. So let's look at example 1. I want to go over a video as well. Okay, so open up a book to page 117. And I'll put my book up here so we can see it. So page 117. Okay, so this is what we're doing here. We're doing P and Q. So notice what they did. They started off with P and Q and then not P because they used not P right here. If it was not Q, then we would use not Q. Okay, and the next step was they went to the inside here of the parentheses. So they said not P or Q, and that's this one right here. So they used the table. And then they did not that. Okay, so the opposite of that right there. All right, and then they used that to answer the question. And finally, they got to this point right here. Okay, so let's try that. So what I want you to do is, first of all, copy what we're doing here. So put page 117, 3.2 truth table, copy all of this down, and then we want to do not P or Q, and then or Q again. Okay, so let's start off with the truth table. So let's do P and Q. Okay, so we have 2 of these. So 2 to the second power, there should be 4 possibilities here. So we're going to say true, 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 false, false, true, and false, false. Copy that down. There's 4 possibilities. Okay, once you do that, now since they have not P, we're going to go ahead and do not P here. So put not P. Okay, so this is an or statement. So that means, let's do not P first, sorry. So if it's true, we're going to say not P would be false. True would be false, false would be true, false would be true. Okay? Now let's expand it to the next part. Let's do this part right here. right here in the parentheses. So write that down. Not P or Q. Okay, let's check that out. So not P is here, or Q. So it's or, so it could be the one. So this one or this one, as long as one's true. So that one's going to be true. This one and this one, so as long as one is true, then we're going to put true. Okay, so this one has one true, so we're going to put true. This one has two trues, so that's going to be true. This one has, let's think, this or that. This one is going to be true. Actually, one of these is false. So the true false or false false, where is that one at? Okay, so let me see. Not P, and I think I ended up doing not Q. Okay, so let me back up. Let's try it again. We want it not P. We want it this one. Okay? So not P would be, this one would be false. Not P, this one would be false. Not P, this one would be true. And not P, this one would be true. Okay, better. Now we want not P or Q. That's these two. So one of them's true. We're going to say true. Okay, and I'm still looking for the false false. So let's see. True, true. Tell you what, we're going to do it again. Okay, copy this down. There we go. Okay, so put P and Q. Okay, so we have P and Q. So it's going to be true, 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 false, false, true, or false, false. Those are the four possibilities. Now we want to say not P. Here's P. So that would be false, false, true, true. Okay, now that we have that, let's go to the next part, which would be this one. So let's do not P or Q. Okay, so not P is this one. So this one right here, as long as one of them's true, so that's going to be true. This one, both of them are false, so that's going to be false. This one of them is true, so that's going to be true. Even though both of them are true, that's okay. And then this one's going to be true. Now we got it. Let's go to the next part, which is this whole thing, which is not all of this, P or Q. So once we do that, and that's supposed to be a squiggly. Okay, so once we do that, we're going to say not this right here. Okay? So we're going to say if it's true, we're going to say false. False, we're going to say true. And then this one, the opposite of that is going to be false, and then false on that one too. Okay, now we have this whole part right here. Now we're going to do the last part, which is the whole thing. Okay, RQ. So here we go. The final part, and I can't fit it in, is all of this. So we're going to take this or Q, and Q is right here. So if you look at this, false or true, either one, as long as you have one, true. True and false, as long as you have one, or false rather, true. False and true, as long as one of them, or because it's or, and then finally false and false will be false. And there we have it, and that should be it. And that is what they have for example 1. Okay? Now we're going to try to do example 2 as well, and then I'm going to give you a little bit of work. So for today, I want you to work. Let's see what I have for you. Page 125, 1 through 5. Let's turn our attention now to college algebra. Okay, so those of you who, and this is all review stuff here. Okay, now did I teach it? No. Am I going to show you right now? Yes. Okay, so clear your calculator. Take 5.4 divided by 3. And I get 1.8. When you divide, you subtract exponents. So that's going to be minus 3. So that's going to be 10 to the 5th power, and that is scientific notation. When you rationalize the denominator, you multiply the top and bottom by the conjugate. So if they say minus, you say plus. And that's called the conjugate. When you multiply this, the outer and the inner are going to cancel. So down here is just going to be 1 times 1 is 1. And then it's going to be square root of 2 times the square root of 2 is going to be negative square root of 4. And a negative square root of 4 is 2. So it's going to be 1 minus 2, which equals a negative 1 on the bottom. On the top, it's going to be 4 plus 4 square root of 2. And that should be good. You can go ahead and move the negative to the top like this. Negative 4 square root of 2 if you distribute that negative, and that should be your answer. Let's go to this last one. This is the cubed root, so it's really 1/3. So it's 16 to the 1/3 power, and it's v to the 5th to the 1/3 power. This is your root. So what you want to do is try to get 3 of a kind. So that would be 8. 8 times 2 is 16. This is 2 times 2 times 2. So the cubed root of 8 is 2. So it's going to be 2 cubed root of 2, because that 2 has to stay. Down here, you're going to go v3 times v2. And then you're going to do the cubed root. Well, the cubed root of v cubed is just v. So it's going to be 2 cubed root of v, or 2 at the top, and then v squared at the bottom. But this v comes out. And there it is, and that's how you do that. We're going to watch a video on graphing calculators. Let's take a look at this one right here. It says, are these solutions? If they're solutions, then both sides would be equal. So this is x and y. So you're going to take the 13 and put it right here. And 10 times 2 is 20. So if you do this, you're going to get 13. Does that equal 20 minus 7? And the answer is yes. As long as both sides are equal, it's a solution. And then you do the same thing with this one. You put negative 3, and then 10 times negative 1 minus 7. So that's going to be negative 3. This is going to be a negative 10 and a negative 7, which is a negative 17, and that does not equal negative 3. So this one works and this one does not work. And that's on page 70. We're going to go ahead and graph this, so pay attention. Even though we have graphing calculators, we want to get y by itself. So you want to subtract 3x from both sides. When you do that, you get y equals negative 3x plus 7. This is your y-intercept, this is your slope. Put a 1 under there. So you're going to go up 7, and then you're going to go down 3 over 1. 1, 2, 3 over 1. And your line looks like that. Okay, let's go to this one. This one is a parabola, and we're actually just going to use the calculator on that one. And we can use the calculator on the first one as well. So let's look at this last one. This is a cube. We want to find the intercepts, and we want to find out if it's symmetry or symmetrical. Today's work is going to be right here. Make sure you copy and draw and use your calculators. Have a good morning.